Okay. So number 8, if you tap number 8, you will have 1000, and you tap number 9, you'll have 1001. Okay. So this is an encoder which translates from binary to rather decimal to binary, usually attached on an input side, no, or an input device. So the second is a half adder. Okay, this is a very useful system because we use this in the CPU. A half adder adds 2 bits. So the addition is done using an XOR, diba? And the carry is done using an AND gate. So for example, if you have 0 plus 1, that's 1 carry 0. Okay. 1 plus 0 is 1 carry 0. Okay. 1 plus 1 is 0 carry 1. Okay. This is the sum, no? 0 when it's black and red when it's 1. Any questions so far? And then we have the full adder. It's called full adder because it adds 3 bits. Usually, there's a previous carry which is added. Okay. So 0 plus 0 plus 0 is 0 carry 0. No? 0 plus 0 plus 1 is sum carry 0. No? 0 plus 1 plus 0 is 1 carry 0. 0 plus 1 plus 1 is 0 carry 1. Okay. 1 plus 1 plus 1 is 1 carry 1. Do you follow? No? Any questions? So the third is a more complex circuit. No? We have a series of full adders. If you look at this, these are white boxes, which means that deep inside them are actually full adders like this. No? This is allowed, no, because there's a full adder white box in Cedar Logic. But we know what's inside this. There's X, Y, and C. C, there are 2 C's. Now C in is which is the previous carry, and C out, which is the out next carry. This is the C out here. This is the C in. Okay. Do you follow? No. So for example, this is an adder subtractor. Okay, you can add. For example, we will add 5 plus 2. Okay. A is 5. 5 is 1, 0, 1. Okay. 2 is 0, 1, 0. Okay. We add them. Okay. So 5 plus 2 is 7, 1, 1, 1. And you take note that the last carry is a red, so it's a positive. So no. So you can also do a subtract. No? Okay. Do you follow? Okay. 5 minus 2 is 3. 1, 1. And it's a positive because it's a red. How is the subtraction done? This subtraction is done using 2's complement. Okay. First, all bits, B0, B1, B2, and B3 are XORed to the subtract. Okay. When you do an XOR to a 1, the 1 is flipped to 0. So this is a 1's complement converter, the XOR. When you do an XOR to when 1 is XORed to a 1, it becomes a 0. When 0 is XORed to a 1, it becomes a 1. So flips, no? So in other words, these XOR gates here convert into 1's complement. Convert the B's into 1's complement when subtract is high. When subtract is low, nothing happens. Do you follow? No? Because it's just as it is, no? The B's are retained. When subtract is low, nothing is added as to the first adder because it's just adding 0. But when subtract is high, the B's are converted into 1's complement, and the additional 1 is accepted as the first carry. Okay, so 1 is accepted as the first carry, thereby adding a 1 after the 1's complement and of B is added to A, which means that the additional 1, it doesn't matter when you add the 1, no? Before the 1's complement or after the 1's complement, it doesn't matter. It just adds 1 anyway. So the additional 1 completes the 2's complement. So the XOR gate converts into 1's complement. The additional 1, okay, during a subtract as the first carry completes the 2's complement. In fact, we can try 2 minus 5, okay? And subtract. 2 is 0, 1, 0. 5 is 1, 0, 1. Okay. So 2 minus 5 is negative 3. This is 1, 1, 0, 1. No? This is black. So this is 1, 1, 0, 1. This is negative 3. Okay. So enable switch. Enable switch is like a faucet. When you say enable, Y receives A. Okay, when you disable Y is all zero, it receives nothing. It's like a faucet on a water system, no? So for example, if you have this, it's like this, no? So nothing happens to Y, but when it's enabled, no? So everything that's changed on A will also reflect on Y because it's enabled. Okay, and then we have a word comparator. This will compare whether A and B are equal. Comparison is done using XNOR. Okay, so the red lines here show that these are the lines that are equal, no? All of them. So if you click this, no, this becomes black because the third bit or the fourth bit are not equal. Okay, so ganon din dito, no? Take note, no? Okay, okay, they follow and they're ANDed together. This compares two variables A and B. If it's equal, the variable equal will be red. If they're not equal, the variable equal will be black, which means it's false. Okay. Any questions so far? So let's go start our next topic, which is computer hardware. Basic lang ito, no? Components of a computer system. What are the different components of a computer system? When you say a computer system, it's any computer system. It's not just like the IBM PC or the Mac OS, no? Okay, the PDP, whatever, no? It's not just like your Windows computer there, no? So generally, no, a computer system has four subsystems, no? You have an input system, a processing system, an output system, and storage. Okay, you see that already, no? This is common knowledge, so I think many of you are familiar with this already. Okay, we will just go through this quickly. What is an input unit? These are the components used to enter data and commands into a computer system. Even voice, no? A mic is also considered an input system. Data can be in the form of words, numbers, actions, no, like clicks on a mouse, no, hovering of a mouse, no, etc. The main function of these devices is to direct commands and data into the computer. No, they are the main entry point. Computers can use their CPU to process this data and produce the output. Okay, the laptop's keyboard, for example, no, uh, a mouse, no, a scanner. Okay, optical readers and touch screens are classified as input devices where humans interact with computers. No? The next is the CPU or the central processing unit. When you have a desktop no computer, you usually refer to that box. No? What do you call that box? It's called the central processing unit. Actually, it's the processing unit in general. No? Okay, so it has main subunits. No? The main subunit of a central processing unit is the memory. Okay, because all programs now are stored programs computers, stored program computers. So therefore, no, all computers will have memory. Okay, because it's where the program is stored. Do you follow? All computers are stored programs, so meron talagang memory. Okay. Next is the arithmetic logic unit. We have discussed this before. No, earlier, no, we discussed the arithmetic logic unit as an adder subtractor. They follow. It's sometimes called the ALU. Okay, it's a circuit made of XOR gates, XOR gates, and AND gates in order to perform the sub and carry, and thereby being able to add or subtract nibbles, okay, bytes, and words. You can compose two nibbles together, connect them in series. The last carry is connected to the next carry and becomes a bigger. It's called bit slicing. The technique is called bit slicing, adding two nibbles or adding two bytes together to be able to perform bigger addition or subtraction. Okay, so that's called the arithmetic logic unit. I've shown you the circuit already, right? Now the control unit. The control unit is also made up of gates, logic gates. I hope I can show you that in my other class. Yeah. it converts now. The control unit converts the opcode, the instruction fetched from memory, which comes as a code, into signals that tell other components what to do. Okay, or it commands the other components on what to do. We have that here. Arithmetic logic unit, flip-flops. Bakit wala yung aking ano? I used to, I may have forgotten where I placed it. But let's try to find one. Okay. Control unit. Nawala na, no? I don't seem to have it anyway. So anyway, it's not important to us. You will somehow discuss this sometime, no? When you reach the appropriate course in digital logic design, no? Do you follow? You will discuss the structure of a control unit. Anyway, no? So a control unit is that component of the CPU which receives the instructions from memory and converts it into signals that activate or deactivate the other components. It's called control because it takes command of all the other systems, no, of all the other components. It tells the CPU to add or subtract, no. It tells the accumulator to load or to store, no. So that's the purpose of the control unit. It's the main backbone of a computer. No? Do you follow? The output unit is the subsystem. Is that subsystem in a computer where output is sent, like your monitor, no? Okay, your printer, okay, see your speaker, and so on and so forth. This is the system where the computer sends the output or is used will use to send the output because now let's look at the internal box, no, we call the CPU. Okay, what are the internal components of a CPU? Is there, no? Okay. So if you look at your motherboard, have you opened your motherboard? It will look like this. You have sockets. Okay, first you have the socket for your CPU. This is where you put your CPU. Inserted. There are slots there. There are holes that you insert the pins of the CPU. Nowadays, there are two brands, no, for CPUs. It's either Intel or AMD. Okay, and then you will have the slot for your RAM. It's where where you insert your memory. Have you seen your RAM? No? If you open your computer, it's just like a rectangular piece of a circuit, no, board, a small board, rectangular board, which has copper pins, which you use to insert into a slot. Now, these copper pins connect to corresponding conductors in the slot, okay, that make them accessible to the bus, no, to the system. It's called a bus, no, that connects them to the system by way of a bus. No? And then you have a PCI slot because there's the graphics card or the GPU. There's where you insert here, no? And then PCI slot, other devices that you want to insert, like modems, okay, PCI Express tayo ngayon, no? And then there's a back panel where you connect your peripherals like your USB, your printer, your mouse, and your keyboard, okay? Do you follow? These are the slots for your drives. Nowadays, we have two types of drives. And there's a particular type of slot called NVMe, which is like a RAM, no? But actually it's actually a hard drive. No? It's actually an SSD. The CPU is often called as the brain of a computer. The CPU controls what the computer does. What it really actually does is receive the instruction that is fetched from memory and decodes it. It's actually a decoder, no? The control unit will decode it and convert it into signals, whether to calculate or process data like load or store, no? It handles movement of data from and into system memory, no? So CPUs come in a variety of speeds. It's called clock hertz. Now, the bigger the hertz, the faster the CPU. Now, the modern Core i7 can come in 3.7. 3.7 ba the fastest, ano? Core i7 speed. Ranges 3.6. 3.6 gigahertz. Giga is billion. They follow? It's which means that in a second, no, in 1 second there are 3.6 billion occurrences, no. What it actually means is in 1 second it can do 3.6 micro instructions. It can perform like a load, no, is a micro instruction, a store, an add is a micro instruction. So which means that if your CPU has 3.6 gigahertz, no, it can perform 5 billion additions or subtractions in 1 second, rather 3.6 billion, no, additions and subtractions per second. No, they follow? Okay, so that's what it means by hertz, no, the clock frequency. Okay, there's an internal clock that times everything, and it's measured in hertz. So if you have a 3.6 gigahertz, no, wow, it's very fast. No? Any questions so far? The Sena is present. I'll call the roll again, no, later. No? So hertz. So there are two main brands now, no, AMD and Intel. So this is like how a CPU looks like. There's an Intel CPU on the left and AMD CPU on the right. You will know that by getting the properties, no? Hardware properties in Windows. Okay. The GPU or the graphics card. When you play Dota, okay, you can play Dota now without a graphics card. Even Minecraft, no. Does Minecraft run without a graphics card? It doesn't, I think. No? Maybe very slow. It's also called the video card. They are plugged into the GPU slot or the graphics card, the AGP card, all graphics adapter. No? Okay. These are the components that make it possible for a computer to generate high-end visuals like very fast, no, rendering of video images like video games. Okay. This is like an example of a GPU card. Nowadays, there are two manufacturers, no? AMD Radeon and ano yung isa? AMD Radeon, is Intel producing it? Ano yung counterpart ng Intel? Anyone? Do you play a lot? Okay, let's Google that anyway, no? Manufacturers. NVIDIA, no? NVIDIA. So Radeon versus Asus pala yung, it's not Intel. Asus is the company that produces NVIDIA graphics card. There are two leading brands, no? There can be others, no? But the leading brands are Asus, NVIDIA, and AMD Radeon. Okay. Which is yours here? Now, mine is a Ryzen, so it comes with the Radeon. Usually, an Intel comes with an NVIDIA. Okay? They follow? So this is connected to the slot in the motherboard. Mixed connections there. Now, the internal memory, RAM and ROM. Okay? Your motherboard already contains a memory which is not rewritable. It's called ROM. ROM stands for read-only memory. RAM stands for random access memory. Okay, they are called primary storage because They are the ones that are directly connected to the CPU, although they're outside the CPU. No, RAM and ROM are outside the CPU. Okay. So RAM stands for random access memory. It needs power. No? It's volatile. It's a volatile type of memory, which means that when you turn it off, it's lost. Temporary storage. What RAM do you have? I have a 16 gigabyte RAM. Nowadays, if you have a Windows with an 8 gigabyte RAM, that's respectable. Okay. RAM can be read or written. Okay. The bigger your RAM means the more applications you can run, because more programs can run. Here is how a RAM looks like. This is a DDR4, I believe. No? DDR4 or DDR3, I cannot see very clearly. No? But this goes into the RAM slot. Now, an NVMe SSD, no, storage device, also looks like this nowadays, except that the contacts are on the endpoints, not on the side. Okay. Read-only memory, ROM. No? The ROM contains programs, no, that are there with your, even without any software at all. No, an example of this program is the boot program or the startup, which loads the operating system into memory and gets it running. No? So it also contains the interrupt handlers, the programs that handle with respect to how hardware reacts, like a mouse click, a mouse hover, or a keyboard tap. No, they follow. So that they are called interrupt handlers. They're stored in the ROM. So there's how a ROM looks like now. Nowadays, I think there's only one manufacturer, that's AMD. It's called AMI BIOS, American Megatrends. Even Intel uses AMD BIOS. Non-volatile, no, which means that even if without power, the contents are there. Okay, you can have a sound card. Okay, nowadays motherboards comes with sound cards to give a better sound output to your, so you can play music better. Storage devices, we have internal and external hard disks. Okay, external hard disks like memory and USB, they're external. No? There are two types of drives, no, for internal devices. Hard disk drives, which are the older ones, they're made of magnetic disks. Okay, while the second one is made of solid state. Okay, like it's like RAM, no? Solid state, but this time it's non-volatile. Okay, but slower. Okay, so the first is HDD. It's made of magnetic disks. The second is solid state, which are made of they're very much nowadays. SSDs are very popular because they have data access. Not always, no, but usually, an SSD will have faster write, and it will have faster faster reads, small writes, small writes, which means that if you write a small file on an SSD, it will run faster on an SSD than on a hard disk. But there are instances where very large data access will run faster on HDD. No? So ito yung HDD. If you open them up, this is SSD, and this is the NVRAM. No? Bago, no? This is M2 SSD. Look at that. It looks like a RAM, except that the contact points are on the end. So there are two types, of SSDs. The SATA SSD and the NVMe M.2. So the slower, of course, the faster is the M.2. Any questions so far? Okay. You're familiar with this, right? So what's the structure of a central processing unit? Looks like this. No? This is a diagram of the CPU. No? Basically, a CPU has registers, the control unit, and the arithmetic logic unit, and the memory, a small memory called the cache, before it's connected to primary memory or RAM. You may ask, why is there a cache? A cache is a small portion of memory because the CPU doesn't access the whole block of memory at a time, no? that's called principality of locality of storage, no? Principle of locality of storage, no? When a program is running, the program runs on a specific vicinity of addresses in your memory. It doesn't go from address 0 to address 1 billion. No, it doesn't. It goes from address 0 to address 10 to address within that vicinity. No? Do you follow? So programs are loaded in small portions called a cache into from memory. No? Blocks. They come in blocks. That is because the CPU doesn't access the primary memory directly. Why is that? Anyone, bakit hindi pwede mag-access? Because the memory is much lower than the CPU. Do you follow? The cache is an expensive type of memory. It's small, but very expensive, which means you cannot enlarge it. Enlarging it will make it more expensive. It's a small, but almost as fast as the CPU. Do you follow? So that the CPU accesses the cache, so that they will more or less understand each other because they are of the same speed range. Unlike the memory, which is 1,000 times lower, no, than the CPU. Do you follow? Okay. Nowadays, there's a hard disk being developed by Intel SSD, Intel technology, no, which is almost as fast as the SSD, as the RAM. Last year pa ito, no? 2019 or 2020. Solid state, Intel Optane. Its speed is it's called an Intel Optane. It's a technology for SSD, which almost comparable to RAM, which means that the SSD is almost as fast. It's like 25% the speed of RAM. We are talking about, by the way, no, memory here, no? The speed of RAM, which means that if the hard disk will be as fast as memory, there's no need for stored programs anymore, which means there's no need for external and internal memory. We can just put them right away together. The main reason why we have primary memory and secondary memory is because the speed of hard disk is much lower, or SSD is much lower than that of the main memory, and the main memory is much slower than that of the CPU. That's why there's a cache and primary memory. So there are three levels, no, of speed from CPU to primary memory to secondary memory. The first being the fastest, and the last, which is secondary memory, being the slowest. Okay. So there are connections that connect the CPU to the to the external components. They're called the bus. Okay. First, let us discuss the internals of the CPU. The control unit. So it's the control unit that fetches, decodes, and executes instructions because of the store program concept. You know? Programs come from the memory and they are fetched, okay, and they are decoded and executed. It's the control unit that tells the arithmetic logic unit to add or subtract, that tells the accumulator to load or store. No? It moves data around, no? From register to register, from register to memory, like the accumulator. No? The arithmetic logic unit, we have seen this. It does the arithmetic and logic, like addition, subtraction, shifting to the left, shifting to the right, inversion, no? Conversion to 2's complement, okay, and so on and so forth. It acts as a gateway between the primary memory and the secondary storage because whenever data is transferred, it goes to the accumulator, and the accumulator is the primary input to the ALU. Do you follow? No. So somehow in data transfer, the ALU is involved. Registers, these are small amounts of high-speed memory contained within the CPU. These are volatile. No? These are memories that are as fast as the CPU. Do you follow? Like the accumulator. No? We cannot use a lot of this because these are very expensive registers. No? Usually a CPU has a typical of 8 to 32 registers only. No? Like the IBM PC has AX, BX, it only has 4 general purpose registers. No? And a few other special purpose registers. So the cache, as we have said, is the small amount of memory which is high speed, which is directly accessed by the CPU or the control, even by the control unit. This allows for faster processing as the processor does not have to wait data from the RAM because RAM is slow. So therefore, the CPU must not wait for it, otherwise everything becomes slow. Do you follow? So the cache is the temporary storage where blocks of data from RAM are stored into the cache before they are processed by the CPU. Okay. The bus. If you look at this, no, these are the buses. We have address bus, data bus, and control bus. What is a bus? A bus is a common set of wires that interconnect components together. Nowadays, we don't have a parallel bus. We have a serial bus. A parallel bus is a bus connected to all registers, which means that are components. However, the disadvantage of a bus is it can only connect to 2 points at a time, one being the source, the other as the destination. So when you move data from CPU to a memory, so the source is the CPU or the processor, and the target is or the destination is memory, or vice versa. But you cannot transfer data from the CPU to the memory to the external components at the same time. No, only two components can use the bus at a time. Why is this? Because we cannot interconnect the CPU directly to the external component and the CPU directly to the primary memory. It will be a very complicated circuit, and there will be no motherboard that can fit such a strategy. So only a uniform bus is used. You will have address bus, data bus, and control bus. Control bus is the signals from data from the control unit, which tells the ALU to add or subtract, the accumulator to load or store, and the others. And then the data bus is used during data transfer, like load and store. When you load and load and store, there are two operands here. There are two parameters: the address to store or load, and the data to be stored or written or loaded. So the data is on the data bus and the address is on the address bus. Okay, do you follow? These are a set of wires that interconnect the CPU together. Okay, any questions? So types of buses, we have the address bus, because during a load and store you specify the address, right? The address is stored in the address bus. And then load and store also, the data is specified. So the data is transferred to it uses the data bus. The control bus is used by the control unit to do the necessary action depending on what instruction is currently being processed. Okay? Any questions now? That brings us to the end, and then we'll have one more: classes of CPU registers. Okay. Any questions? I'll do the roll call again now, as soon as I finish this. Okay. Registers are fast computer memory that the CPU accesses. There's a few of them because they're very expensive. These are the different classes. When you have main memory, they are not loaded directly to the CPU. It comes through the cache. This is the cache, and then it's loaded to the registers. The ALU has the accumulator register. You have a program counter, memory address register, memory data register, and so on and so forth. CU stands for control unit. Okay. What are the different types of CPU registers? First, the very common one is called the accumulator. Okay. Any load and store uses the accumulator, and the accumulator is directly accessed or rather connected to the ALU, arithmetic logic unit. We know this already, starting from the IAS, or rather, where was this first invented, the accumulator? It's in ENIAC. We follow? Because before ENIAC, you will have a separate register for input. You'll have another register for output. Combining them together calls it the accumulator. The accumulator is that register used both for input and output to the ALU, or the arithmetic logic unit. You know this already, right? I've been using the accumulator. Now there's the memory address register. When you access memory, you specify which address, whether you load or store or access an instruction, you need to specify the address. Where in memory, when you say load 1000, which means that we are going to load memory address 1000 to the accumulator. Store 2000, which means that we are going to store to the address 2000 from the accumulator. Okay? Any questions so far? No? So the 2000 and 1000 are stored. No? Okay? The addresses are stored in the memory address register. Inside, no, we do not access the memory address register ourselves. We can only access the accumulator and the data register. But the memory access address register, we do not access it. It's the CPU that controls it. Do you follow? Now the memory data register. During a load and store, aside from the address, we need the data. So you say the data usually comes from the accumulator, right? And the contents of the accumulator are transferred to the data register. Any access to the memory, because memory is not accessed directly, no? We can only access the memory using the access address register and the data register. You follow? Okay. So this stores the data that is going to be stored or transferred from to random access memory. It's also called memory buffer register. So when you say MDR or MBR, they mean the same. Now, the MAR and the MDR are partners. No? In any memory access operations, they are both used. Hindi pwedeng isa lang. Okay, they together facilitate communication from the CPU and the main memory. Okay. 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 The next is the general purpose registers. No? So in the IBM PC, we have AX, CX, BX, DX. These are the registers, general purpose registers. Nawala yung ating mouse. They are used as temporary storage. In general, they can be used even as accumulators. No? They can be used as data registers, no? But they're not used as address registers. No? They can be used for indexing. They can be used to store values of variables. That's why they are called general purpose registers. The accumulator is not a general purpose register. It is only used for input and output. The address register only stores an address. The data register only stores data. The general purpose register can be used both. No? You follow? The program counter. The program counter is that counter, hidden counter, which stores the address of the next instruction to be executed. Because of the stored program concept, the computers process instructions per instruction, and the address of being executed is pointed to by the program counter. It's the program counter that tells the control unit which next to execute. Okay, what is going to be executed next by the control unit? The program counter tells it. In the IBM PC, in the IBM PC, which means the PC you have now, the program counter is also called the instruction pointer. Okay, so interchangeably, sometimes you call it program counter, sometimes we call it instruction pointer. Okay, any questions? Instruction register. Now, the instruction register, if you look at the CPU, it's here. This is the program counter. This points to memory. Now, when the value being fetched from memory, sometimes it can be data, sometimes it can be instruction, right? Diba? When we say in our programs before, in the IAS, in cases when the value being fetched from memory is an instruction, the value is sent to the MDR, but it's copied to the instruction register. Do you follow? Because the instruction register contains an opcode. Okay, an opcode, an operation code. Diba? The instructions come in opcodes and operands, right? The opcode goes to the IR. The operand goes to the MDR. Okay? Do you follow? So, ang operand papunta sa MDR, ang opcode papunta sa instruction register, where it's being decoded and sent to the control unit. Okay. So for example, the opcode can be load, store, add, sub, load accumulator, store accumulator, no? Add, sub. The instructions that we've been discussing in the IAS are actually stored in the instruction register before they are being decoded by the control unit. Remember, the control unit actually is a decoder, which activates the corresponding signal to execute the instruction at hand. Okay? Any questions? No? Instruction register, doon papunta. Okay. Okay, you can do, we have a lot of material, no? Meron tayong third-party material, no? What are registers and RAM? I suggest you go through this, no? How computers calculate using the ALU, the central processing unit, okay? The instructions and the program, how are they being executed? You go through these videos, no? These are very helpful, no? Okay? And that formally brings us to the last part of our third topic, no? Which is logic gates, Boolean algebra, and computer hardware. Okay? So any questions? So we'll not have meeting on on Thursday. Okay? What you will do is do the practice test. Okay? Do the practice test. There's a practice test there. And on Monday, Monday and Tuesday, we will have our third formative test. Those who are not yet able to take or to pass the second formative test can have the retake starting tomorrow. Okay, I've read the email. I'm going to email you again a password. Any questions? So anyway, let me call the roll again. Alcantara. Alcantara, are you there? You're there. Asombrado. Bualan. Kabuga. Charles.
Present, sir.
Kalubag. Hazel. Kalubag. Chang. Chang. Chavez. Shan, you're there.
Present po, sir.
Thank you. Cordova. Dishar, you're there. Jerome.
Present, sir.
Digman. Eloha. Ramis. Estores. Gutera. Labuguen. Lim. Mercado. Narca, you're here. Si Narca.
Present, sir.
Perez, you're here. John
Present, sir.
Simon. Yap. Okay. So on Thursday we'll have no online session, no? But you do the practice test. Okay. No lecture on Thursday. You do the practice test, and we'll have our test on Monday by next week. Okay. And then by Thursday we'll have a new topic. Any questions so far? So good luck on the third test, no? Those who are not yet able to pass the second, I'll give you another try, okay? Starting tomorrow. So see you, everyone.
Thank you, sir.
Thank you. No, I'll upload.
Sir.
Sir.
Good luck on the
Hey,
test.
Teachers Day, sir.
Okay.
Yes, sir.